Okay, I think we're working. Not 100% sure. Give me a main overview. Hello. Audio good? Well, video's working excellent, which is good. How do I tweak this thing's focus? There we go. No sharp. Okay. Yes, looks like we're actually holding at upload. Okay. I'll give it a bit while everyone else shuffles back in. Now there's my 5 milliwatt. Ugh. Hello, hello, can you hear me? Test. Okay, sweet. Oh. Alright, try that. My lapel mic was over on my microscope. Better now? Okay, cool. Tell the boys to show up. Add more gain. Download more RAM. Give me a sec. I bet I know what this... I'm going to go check that. Sound settings. Manage sound devices. Nope, that's not it. Nope. Yes. That is at 100% boosted. Yeah, that's better. Go back. Sound control panel. Make sure my gain's actually set up. Oh, hang on. I figured it out. Levels. Oh, my microphone boost was off. Test that. Do we sound better? Hello. Checking audio. Okay, now we're actually in the good zone. Let me turn that up just a smidge more. Turns out my amplification was way off, and I wasn't actually working correctly. Oh, we're clipping a little bit, so I'll turn that down just a smidge. All right, we're speaking normally. Yep, there we go. Okay, sick. Hello. Welcome to another stream from the lab. This time with no dropped frames and actually good encoding software. I switched over from that tiny little computer to a proper GTX 680 machine. And hopefully that'll work better. It may or may not. I don't know. We're here to find out. Today we're going to continue our work on redoing that rework, this time with 100% less gunk from the aluminum tape. We're not repeating that, hopefully. But we will, hopefully, also have the correct size ones. I know they're the correct size ones because I bought them, this time, the correct ones. Let's switch over to a closer view. I'm going to check that router board over there. I'm going to switch this one back to autofocus mode. That is not working too well. So I'll put this over here. here like this, and then tweak it from there. Alrighty. Let's get my soldering stations heating. And move my control out of the way. Audio quality and video quality looking good. It's not turning into pixels when I move stuff around, is it? All right, first up, I need my flux. We'll also need scalpel, capped on, ouch. Flux 1, flux 2, and the solder. Coolio. Let's see, turn my airflow down, and I want let's go 400. That's a good temperature there. Well, first thing I'm going to need to do is get out some of these. So this time, I actually got the correct chips. Wait, did I not get the correct ones again? I think I'm an idiot, guys. But these are definitely the right ones. These are 100% the right ones. I think I'm just an idiot. No, these are 100% the right ones. Why? Hold on, we're switching it back over to the microscope view. It's time for bro moment number 5, because apparently that's all my streams are now. These are just real bro moment hours. So, here's the ones I've got as replacements, and I'm going to go grab one of the initial ones. See, even if you are, quote, 5-head, you can still make really dumb goofs. Why are things under liquid? Because I was cleaning them with flux. It's isopropyl. So here's the original one, which looks to be a, if I had to guess, TSOT 20. Oop. And move this down. So yeah, we have the original one, the new one I got, which is still the wrong size, and then the first one I got, which was the wrong size. I made sure I got the codes right, but I think Cloud Schwartz was wrong, because this is not the right part. So I'm going to have to go find, figure this out. So now I've got to figure out what I'm going to make this stream, because I was originally going to rework this FPGA. Yeah, at this rate, I will be splitting the difference and getting it right on the money. So I need ideas on what to do as the stream now, because clearly FPGA rework's not happening. Take some snips, cut the big one smaller. I don't think that's the way silicon works. The heck's the... Oh, there's the memory of this thing. I honestly don't know what I'm going to do with the rest of the stream, because I was originally planning on getting this thing working, but now I'm not so sure. Well, on the good side, we know the stream hardware works real good, which is a huge plus, because that was slightly concerning previously. Last time we did get the transimpedance amplifier working, which we have working now. So I guess we could just build out the summation thing and work on the negative voltage stuff as well as the mixer, because I have a bunch of mixers out here now. I think we're just going to go with some analog stuff this time. All right, no FPGA stream. So I'll be right back while I update the stream details. Continue to stare at the shiny FPGA in the meantime. Ooh, shiny. Okay, we back. Stream updated. Let's see. Well, first up, we're gonna switch this back over to the desk camera, and we'll go get some breadboards. I don't know why the focus on this thing's so terrible. But alas, FPGA stuff will have to wait again, because clearly I do not know how to make this work or choose the right parts. I have no idea how I've managed to screw it up this many times. I'm pretty sure it's because I'm just an idiot. Okay, well, let's see. Shove that out of the way. Shove that out of the way. Don't need that. Don't need that. We've got breadboard, analog stuff there. That's still toasty. That's some more stuff there. Nope, nope. That's my good fit. Where did I put my... Oh, there's the rest of my bridges. I believe this is my... No, that's not my voltage inverter. Where did you go, voltage inverter? Oops. Nope. Okay. Well, first thing I need to shove some of this stuff out of the way. That's one of my parts I'm going to need. TL072s, those are just regular amplifiers. Here's my voltage inverter, which I might need to fix. Yep, that does need a fix. So, let's see. Okay, that running there. I need to go grab my multipliers. So in here, I should have some, yep, 8680s and some Raytheon multipliers too while I'm in here. TL702s. Yep, here's my Raytheon multipliers. RC4200s. And my other multiplier parts should be... Nope, those are my other ones. RC3117s. Brett is now able to fly airplanes. Please don't actually fly airplanes yet. You are not quite ready for that. But yes, congratulations, you done it. You now know how to land. Now all I have to do is learn how to do air-to-air dogfighting. It only gets more complicated from here. Okay. So first thing we need to do is switch, bring this in closer. We are back, this time with much chaos still, but that's par for the course in my lab. Turns out I've screwed up again and got the wrong part, but that's pretty par for the course with me. Where's my cleaner? Okay. Fix my negative voltage. Brad, why did you kamikaze a train? I have questions, concerns, comments, all of the above. Were you training for something? Hey. Okay, let's see. I need that there. That there. And let's say I'm going to move this more centrally located and plonk down a 8633 over here. And a RC4200N. Let's switch this over to the other screen so you could see this, because I think this is the only chip I own that has a Raytheon code on it. Where did I put my mouse? Oh, it's way over here. Why is that still here? Check that out. Analog multiplier from Raytheon. On second thought, this actually might be a re-topped one. We can find out. I've got acetone. Let's see if this thing has fresh blacktop on it, or what it really is. Let's see. Ooh. Well, the black gunk is coming up. Oop. It's getting a little snarled. Give me a sec. Ouch. I think this thing might be legit. Well, we'll find out when we test it in the circuit. Yeah, we'll see. Switch back to the overhead view. We will compare this one versus these supposed AD633s because I am bored. And I got these for literally like $3. Figured it'd be fun. Well, let's see. On this one, if we switch it back over, it should have just cleaned up and intensified the printing, which it did. I kind of wonder what happens if I... Yeah, it only cleans up and intensifies. Maybe a little bit of blacktop comes up because it's dissolving the features. Yeah. Fascinating. Well, the entire painting didn't come off, so we know that it's not one of the terrible blacktop types, which are absolutely abysmal fakes. Although sometimes you can actually get real ones that are just rebadged because their original badging dissolved or got scuffed up during their extraction. All right. I'll put these to the side. Okay. First thing I'm gonna do is look up some schematics. I need a 8633 That's division. I need to multiply signal by signal. Okay, so let's see. Y input's a positive input, so X1, Y1. Then that gets output. So I need 15 volt positive and negative. So I'm gonna go grab my voltage switcher. Don't remember which one has which drive voltage. find out when I instrument one. Designed one of these back in the day. So now we just gotta rework this a little. First up, though, we need to go and get some power into this thing. Require additional pylons. Meter. Okay. Okay, so that's the negative side. Got it. All right, figured out which side's which. I need to just grab it in though. Cool. Now I can go 633. I need decouple the input with a 0.1 microfarad capacitor. Man, why is this thing so just bad? Do I have shmoo on the lens? No, I think it's just a terrible camera. Huh. It's worse than I remember. Okay. Hardscape. Let's see, where did I put my other capacitors? My polarized ones. I've got a big bag of just ceramics somewhere. There. Okay. Parts. See, I need, we've not dropped any frames, and it looks like we've been holding good health uploading at 1. That's 1.8 nanofarads, 82 nanofarads, 680 nanofarads. A couple puffs. Nanofarads, 10 nanofarad. One nanofarad. Oh, now I've put this there. value did I need? I need 100 nanofoot. 22 puff, 33 puff. I think the code I'm looking for is 104. 680, 820, 68, 100 puffs. That's, yep, here we go, 104 code. These are the ones I'm looking for. I really need to figure out a better way of storing all this stuff. Still 0 drop frames. Very good. Let's see. So I need 2 of these, decoupling both my inputs, because I only want AC in to get DC out. Let's see, Y1, let's see, X1 positive here. So these are my 2 inputs. I'm going to grab 2 inputs. And yellow. Okay. Then I will make, what color should I make output? I really need to just overhaul my entire lab, which I'm in the progress of. First thing is getting a new workbench that's not as terrible as this one. Oh, I need more light. Hello? Weird. Switch this up. Oh, it came unplugged. Duh. That would indeed cause problems. Give me a sec. I gotta plug one of my lights back in, because it came unplugged when I was doing my testing. There we go. Alright. So we got that, and now I need some output pin. We will use orange as my output. So that's pin 7. That's my output. I'm going to use, got my grounds. It's not the one. I need another. My output here is going to be common mode signal ground, which I don't think is Z. I want. I'm going to go grab the data sheet. Okay, Z is ground. So this one needs to be tied low. Cool. Now I need, I'm going to use green as my voltage. So you're going to be, and you're going to be -15. And this one needs some pin headers soldered on. Okay. Just gonna pre-tin these to make it easier. Okay. So you are positive 15. Ground negative 15. That needs to be cleaned up a bit. It's got just a bit of solder on it. Okay. Negative 15, so these are my two signals in, and I need to extend my ground reference. Whoops. Where did I put my microphone? That's over here. Where is some more header pins? I'm going to go grab some more headers. Because clearly I need them. Yeah, one of my next projects is to figure out how to get screen capture off of my test equipment rack. You know what, I'm just going to use this as my extended ground reference and keep this one with the length of the others. So we've got our signal ground there, signals in and signal out. So let's see. Decouple both these to ground with more 0.1 microfarads. This thing needs a lot of decoupling. So let's see, you need to be 1 pin bridge across and 2 pin bridge across. Okay, decoupled. Now I need let's see, so if I grab some meter probes, we're building a analog multiplier to test it. Then we're going to go and check to make sure these things are not actually just fakes, which I'm half expecting they are. Just for lulz, I picked up some of the cheapest ones I could find on the usual suspects. But I know these MC1496s I have work. And then my voltage inverters work. I also want to try these Raytheon chips, which were interesting. And I figured, at like $8 for 5 of them, why not? Okay, that done there, that done there. Now we just got to run some signals. Let's see. I need 2 signals from my SIGGEN. And some T-junctions so I can extend my oscilloscope probes. If I did this right, I should see a DC and 2 times the input frequency from my system. Okay. So we're going to shift this over to here. Okay. Rotate this a little bit. I'm going to switch over to a different camera in just a second so you can see what's going on. Or rotate this up over here. So what I'm doing is connecting that over there, getting, oop, damn it. Okay, good, not unplug anything. It's going to stay there. But it's something that holds it down with a little bit of more force. Because that was not optimal. No, it's not going anywhere. I need oscilloscope probes. Hello? Did I forget to plug in my Rigel? I think I forgot to plug in my Rigel. This one should be my signal out. I'm going to go plug my Rigel in real quick. Yep, it has been forgotten to be plugged in. So I've now got all of this battery backed. So all of these systems here are backed up by UPS down in the bottom over there. And controlled by this computer here, which was my previous streaming computer, although it's currently under overhauls. Yes, cool, thanks. Okay, bring this one down. What volts per div are we? 5 volts per div. I'm going to go with a 10 hertz. Let's go with actually 110 kilohertz and a 112 kilohertz. Amplitude 5, offset 0, duty 50, 50. Okay, cool. Okay, those are disarmed. Outputs are ready. Let's go. We'll go normal will acquire normal, and I want, give me some faster time. 5 milliseconds, sure. And then I need some power to that. So I'm gonna go grab where the heck did I put that stuff when I need it? You know what, we're just gonna, because we're not gonna be drawing a lot of current, I'm just gonna use random cable. Excellent. Yeah, so it's not a true sine wave UPS because all these things don't really care that much, and my true sine wave UPS is over on my server rack on the other side of the lab, way over there. Because that's where I actually have my really, really important stuff. As is right now, I don't do anything super intensive, so I don't know if I'm going to even use the true sine wave UPSs on this stuff. When I eventually upgrade this stuff more, I will switch over to true sine waves though. But as is right now, it doesn't quite make sense with my project funding. Stay there. Okay. Now I can grab my power source, clip it in. All right, time for smoke test. 12 volts, and I want, let's go 150 milliamps max. Oh, let's see, temperature. It's fine. Let's go 200 milliamps. Nope. All right, let's probe it out, see if anything's wrong with it. Ground. Let me switch you into continuity mode. Yep. Nope. No short there. No short there. No short there. No short there. Interesting. Give me a sec, I'm gonna switch it back. We're gonna take a look at this some more. I'm gonna double check it against the schematics. Okay, we're back. Let's see what we got. Multiplier connections. Oh. I need to ground my negative inputs, which I only had them floating previously, so it might be trying to multiply things by 0. Which can cause problems. and it's not generally a great idea. So let's see. This one and this one need to go I need another one more. Actually, give me a short one. No, 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 no. Too long. Too long, too long, too long, too long, too long. Slight downsides to having so many cables and stuff is it's hard to find the length you need. Way too long. Too short. There we go. Here's what I'm going to do. Tie this over to here, and take these two, also tie them over to here. Cool. Now I can actually just drop that out there. Cool. Now we've got our signal ground and our oscilloscope ground. Okay, let's try this again. That's definitely positive, that's definitely negative. These are definitely connected. That one needs a little bit more solder, I'd say. Yeah, it's just tentatively holding on. Much better. All right, switch it back over again. Attach oscilloscope ground. Okay, so sorry about the terrible workshop again, because overhauls are underway. Okay, let's common signal ground. Signal 1, signal 2. Okay, contact. Oh wait, these are not connected. Nope. We are still going into overcurrent. Temperature of that is not up. Arm those. We can also try a diode ring mixer, which I might try later. Just for laughs. You know what? Let's try removing the negative rail, just powering up there. Nope. Still draws a lot of current. Let's try removing both the power rails and seeing what it does. Interesting. That's definitely negative. Check the data sheets again. VS is definitely going to negative. You are a sine wave. Channel 1 is a sine wave. Okay. So I'm not trying to input any wacky, impossible things it's not supposed to be able to do. That is definitely decoupled correctly. divided by 10 volt plus Z. Z is definitely pulled. You know what? I'm going to disconnect Z. That might be my problem. Where the hell do you connect the ground on that anyway? Huh. So it's floating aside from VS, and yeah, this thing's floating. Optional summing input. So I bet these things are actually just holding it in a short. I'm going to grab another black cable in here. Hopefully I can find a nice short one. Cool, found one. Tie that one there. Those are held low. Ooh, it spooked me. Okay, let's see this. On. Nope, we're still drawing too much current. Z is not held low now, though. So now things get interesting. That is being decoupled, yes. That's being decoupled there. Z, summing input. Divider. Automatic gain control. Nope. We're just gonna go bet this thing's a fake, actually. So let's go with, yeah, that's not doing anything. Yeah, we've got a statistic on. Yeah, it's at 400 hertz. I'm telling this thing I want it at. Yeah, it's not modifying any with the signal. That looks like just overtone. Yeah, that's definitely not mixing. And the chip's warming up. I'll swap in a different chip, see if that does anything. But I'm going to bet no. Where did I put them? Here, there. I don't have the highest of hopes for these, because these were bottom of the barrel discount ones. I mostly bought them just as a curiosity. But I swear, if this works, I'm going to be mighty surprised. Well, nope, that's getting hot. I think these are fakes. Shocking. Literally nobody. Well, that's not hugely surprising. Also, this little Murata converter is power limiting. Whoop. How do I twist this thing? Oh, wait. I can leave this thing in its down position and then just rotate it up when I need it. Yes. Excellent. Sweet. That makes things way easier. Cool. Okay. So, well, that was a bust. Switch that off because I don't need that running right now. So I guess we'll try the Raytheon multiplier. Stand by. I need to go grab the data on that real quick. You are a RC4200N. Well, while that's downloading, I can start moving some stuff around. I'll clean that up a bit later. So we know these things are fake, which is an interesting turn, but not entirely unexpected. We have still dropped 0 frames, which is very nice. Okay, let's see. Where's the schematic? Turn this thing into a multiplier. It's a current multiplier, voltage multiplier. Voltage XY output. Divider. Wait, this one's a current mode multiplier, so it might not work. Instead, I think we just might re-implement this boy as a lock-in product detector, as the app note says. Let's see if I have that data schematic here. Nope, that's my FLIR capacitor charger. Where are you? It's the pulse mode. Nope. Here we go. This is the key. Or that's the key. we're going to implement this one, which I found, I don't remember where, but we're going to use that. So first thing I'm going to do is dismantle the previous one. I will need that to create my negative 8-volt rail. Although I probably should stick a bigger capacitor on that. I've got one that I know works up here. Thick boy. Can I refocus this? Autofocus off. That's sharper, kinda. Advanced settings. Can I bump that up a bit? That's not helping that much. A bit, brightness. Interesting. Hey, start to see the actual LED frequency there. Reset it back, auto mode that. Now turn up the brightness. Why are you so dark? Maybe because it's all the white and light. Autofocus off. I need a better webcam for this. This old Logitech one is not great. Anyway, let's see. Input carrier, that's our reference signal. So our external signal in. It's going to get bridged with 251 ohm resistors. 12 volts. 12 volts there too. Bias that. Where does the negative 8 volts go? The top. It's negative voltage out. So VO is positive here, but you bias that 12 volts. 1K gain. DC blocking caps on reference signal, and then our actual signal, which will come in from our photodiode. And then I need to add a integration amplifier at the output to give us the average after a few cycles. Back of the phone over there. 6K bias to ground. Where's this thing's pin 1? Just realized that. Is that pin 1 up there? So yeah, that'll be signal out here. Why is that so dark? Who designed this thing's white balance? No, I don't want right sound. I don't want right light. No, don't look deep fried. I want normal. Too much contrast, looks terrible. Up a bit. Yeah, there we go. go. That looks fine. I don't know why it's so set on just like looking terrible. And why it's so fuzzy. That's probably just the optics. Anyway, we got our signal out. I'm actually going to move this more central at first. Three and 4 on this one. Need to be bridged into a bigger capacitor, so I'm going to solder on some leads. A spring. I really should just overhaul my lab already. Bread, you had ribs. I'm jelly, especially really good Potter's ribs. Very jelly. I've got barbecued burgers scheduled in like an hour-ish. So we'll take a break from streaming then, and we'll go from there when I get back. Okay. Janked it into place. Poggers. Now I can plug that in there and that there. Now we've got more capacitance to bring our voltage levels up. No feedback required. You are a TC766. Got to go over that data sheet. Charge pump, DC-DC voltage converter. I've validated this one extensively. With the larger capacitor, it works great and outputs, what is it? 100 millivolts less than the input when correctly configured in this format. I've got this initial one and a secondary one. Works great. All right, let's see. Ten microfarad pin 3 is tied to ground, which is initial one here. Pin 6 to ground. Okay. I need 10 mics, polarized 10 microfarad on the output. Where did I put my capacitor box? Actually, I probably got, these are all Tyco capacitors. Let me check my big ass box of capacitors before I dig into my good stuff. 4,000, 3,000, 9,000, 15. All of my middle-sized capacitors, too large. Semiconductors in there. I need 10 mic. I need to figure out how to add a wireless microphone in here. Even better, just figure out how to add also a wireless head camera. What's the microphone in here? No, those are 100 micros. Way too big. Where did I put my box of capacitors that I had from the salvaged parts? Those are XMAs. I know I had just like a scrape bin where I dumped all the stuff I pulled off. I have to check. Stocks. Resistors. Nope. 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 I know I had them. Because I was putting them in a box. I just do not remember where. Let's check in again. They are somewhere. Where that somewhere is, I am not sure. Oh well. Let's just dig into the good stuff. Unless... No, those are all non-polarized. I need a polarized one for reasons. That's 1 microfarad. Micro. Got it. We back. 10 microfarad on the output of this goes pin 5 to ground. Okay. RL. Let's see, what resistor do I need? 8 is supply. So we'll mark that as orange. This will be power ingress. Or actually, no, let's mark that red. We will use analog power. Let's see, 6 is ground. Tie that to our negative rail up here. Let's see, power here is VEE, which is 14 here. VSS is CNC car input, negative 8 volt there. We have a ground to tie. Bias gets tied to ground. Got some 51 ohm resistors around. I think over here. Let's see. Yep. 51 ohms. $3.8K. Where did I put the rest of the 51 ohms? They are around. Well, worst case scenario, I can just grab some more 47Rs. Use those. Capacitance are U. 550 micro. Don't need that yet. Oops. Cable snags. 0.9K. Nope, 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 nope. 6.8K, nope. 1K. That's not it. 0.8. Where did I see those 47Rs here? There. This one goes from signal input, which is pin 1, to ground. Ground bias. And then signal input 2 which is pin 4 gets also tied to ground. Okay. This one's a couple megs, so that one's for a different project. What are you two? $390K. Okay. 6.8K. It's not it. 3.9K? Yeah, 3.9K. So I need one of these, two of these. both be cleaned up a little bit. Okay, so let's see. Signal out is going to be third from top. Bias to positive 12 with the 3.9K. The other 3.9K is negative signal out as 6. Pin 6 gets jumpered to plus 12. $1K across the gain. Except this one's not ready to be an output yet. $1K across 2 and 3. Bend them inwards. You know what? I'm probably just going to solder these in and then bend it up so it stays out of the way. Yep, there we go. So that's the gain adjust there. 6K8 to ground. Hang on. Nope. Nope, nope, not any of those. Pin 5. To ground. Okay. Let's see. 7 is not connected. Input carrier. 1K. So we bias this with 6. Interesting. I need another 0.1 mic. Pin 8. Let's put this down here. I need 2 1Ks. One 1K goes to 12 volts. Other 1K goes to ground. Slightly odd. Let's expand that out just a smidge. I'm trying to do this in analog before I try just doing it in digital, which I might end up doing because analog is a bit of a pain. Since this one's just negative voltage, I'll make this one the white one.
Arsenio?
Hold on.
I said you take these boxes out. We're gonna eat in 5 minutes.
Sick. Ooh, burgers are almost ready. Pretty poggers. Hype for that. Let's see, where did I put? Tied to ground. Reference signal. I need another 0.1 microfarad. Oop, no, come back. Alright, so let's see. You are pin negative to the reference side. 10. So let's see, I need a 51 ohm to there. Which, not these 1K, there's 6.8Ks. Where did I put those? 47 Rs will work fine. Between that and pin 8 here and up here goes like that. Now I also need bridge from the front of that to the other one. I use a green. Or yellow in this case. That'll work fine. From up here to here. Now signal input is going to be orange. And no, reference is going to be orange. Signal input will be green. Or better yet, blue. Where are my tweezers? I smell burgers. Get tied to ground. So that's signal input and then carrier input, and then we got signal out. Let's see, pin 3 needs to be biased via 3.9K. To 12 volts. I think I'm going to finish hooking this up, then I'm going to go eat food, which is third from top. Oh, that's already hooked up. Sick. Now I'm just going to bridge these across with a red. I need a black to do the same. Common ground in. And I think we will have a long red one to tie in 12 volt supply. No, that's not it. Ah, come on, where are you at? Or maybe just a really long green one as the 12 volt supply. Which one of these input pins? Pin 8. Hold on. So that's 12 volts. Input, reference, output, signal. Okay. Give me a second while I make a... Stand by!
Here's the top search
Alright boys, we back. I've eaten hamburger, potato salad, and garlic bread. And it was good. Okay, let's see. What's next? 618K. Okay. Whoops. Alright. It's time to hook up things again. Let's connect everything. Close enough. All right. I'm probably going to grab another ground lead. Signal input there. Channel, no, I'm going to switch these around. Channel 1 is going to be my actual signal or reference, and then 2 is going to be actual signal. Okay, now if I supply it 12 volts, means I need another ground line. This is 12, and then we need one more ground for the oscilloscope. Okay. Everything's connected. I'm gonna push this up over here. Let's see what we got. 1 volt per division. Let's pull this down a bit. And I want to go, we'll stay on normal for the time. Arm current, let's go with 100 milliamps. Okay. So we're pulling very minimal power. Actually, let's go 2 volts. All right, arm 1, arm 2. Auto acquire. Don't need channel 3 on right now. Move this. Let's change these frequencies. 40. Nope. Not responding. Channel 1. Let's go with phase difference. Nope. And we are operating in kilohertz range. I don't think it's working. Yeah, I don't think that's working. Nope. Wait, hold on. I found the problem. I'm not supplying... I'm an idiot. I figured out my problem. Pin 8 is... Let's see, 16? Yep, I figured it out. I'm an idiot. Okay, you need to go to pin 5. There we go. I'm an idiot here. What I was trying to do was run this without supplying it any power. And I was wondering, why is it not working? Turns out I'm just an idiot. I are the big stupid. This is another big 3-head moment brought to you by Arsenio. Let's see. Pin 8 is supply. Okay, let's try this. Contact. That looks like a short. Okay. And this, kiddos, is why you should get current limited power supplies. Well, disarm our signals. Nope, nope, nope. Nope. Okay. So, let's see. I'm going to push this actually back a bit so we have visibility of this. So that one's ground. That needs to be tied to ground, yes. And we've got 5, which is supply. Wait, what? Did I? No, 5 is output. 8 is supply, yes. 2 and 4 are jumpered, with 4 being the negative side, yes, and yes. And then we've got pins 6, which is tied to ground, and 3 bridged. 6 and 3 are bridged. 8 is V+. Hold on. I think I need another rail. Maybe it's just not inverting. This is probably going to be noisy because I think my fan bearing is shot in this power supply. So, yeah. All right, tie this one to there. Cool. Yes. That is one broken fan bearing. Let's go negative 8 volts, so I need 8.11, and we'll limit you down to 100 milliamps. Contact. I think it's shorted. Nope. You gonna finally stop making noise over there? Or are you just gonna keep complaining? I think it's just gonna keep complaining. Need to swap that fan. Okay. There it goes. Now it's stopped complaining. Channel 3 does not need to be connected. Disengage channel 3. Down. What are we getting out here? You know what? I think I'm just going to design a PCB for this because this is kind of a pain in the ass. Back to bench view. It's time for some big things. So we know we have this working, which is good, so I can get transimpedance amplification. We know that my multipliers are trash because they're fakes. Surprising literally nobody. But what's really important though is we figured out that this new streaming PC is working excellent. That's very good because that allows me to actually stream without having to deal with any of the choppiness in theory. Don't know if that's just turning everything into a pixelated mess, but I'd appreciate it if chat could tell me if this is just becoming pixels when I move this around, or if it's actually, you know, not falling apart when I do anything that would cause encoding to hiccup for a second. So the FPGA didn't go together because I got the wrong parts again. And the rest of this stuff hasn't been quite configured yet. I'm going to work on getting that stuff ready. And should have that up and running pretty soon. I need to swap over the fan for my power supply there because that's kind of noisy. Here, I'll move my mic over there. Hear that? Yeah, not quiet. So that's going to probably be swapped over to a Noctua or Dark Rock Be Quiet. And I'll probably add some fans to my bench multimeter and get those over to the newer stuff as well, so I can make my entire lab quieter. My DDS signal generator needs some fans too because it's getting a little toasty and getting some instability. But that's probably streamed for a different day. At the moment though, I think I'm going to call it here. I might stream tomorrow or the day after work. When I've got some PCB design, I'll probably just actually drop down this lock-in amplifier, this one, onto a circuit board and use this as just like a PCB for practice usage. Because, yeah, trying to lay this out on a perf board or whatever sucked. And PCBs are cheap enough now that more practice is always good. So that'll probably be all for today. Let's see, we're at like 2 hours of streaming. Not terrible. It feels good to actually be streaming and not having to worry about network infrastructure crapping out so much. Don't know what the hell was going on earlier, but now we're actually working correctly, and looks like we've been holding at a 1.2 megabit per second upload for the vast majority of it. Drop 0 frames, and yeah, this NVENC is looking really good. So I think that'll be all for today. Remember to check out theflametrench.com, see what we're up to there. Patreon.com/theflametrench to support us. And don't forget to like and subscribe to the YouTube channel. All right, guys, that'll be all. Thanks for watching. All right, how do you stop this thing? And